Welcome to this capstone course video created to summarize the theory of evolution and why this theory is so important in earth science and geology. To begin with, evolution, this is a theory that states that all species on Earth evolved from a single organism. And it's important to keep in mind that this is a slow and random process that over billions of years has resulted in all of the plants and animals and just species that we can see on the planet today. How it works is the process of natural selection, which states that organisms have random gene mutations, and if that mutation provides the organism with an advantage, they are more likely to spread that mutation to their young, and assuming that their young can then also hand down that mutation to their young, then this can slowly, over vast amounts of time, lead to the creation of new species. Again, it's a slow process. It's driven by chance. These mutations are random, right? So we might not have any for a lot of generations until suddenly you do. So the process just requires a lot of time. It was actually one of the early arguments for why the Earth needed to be old, is because only an old Earth will provide enough time for species to evolve via this process. This theory also helps us to recognize and make sense of the fossil record that exists. So when geologists go out into the world and they find these fossils, knowing what evolution is and that it has occurred helps us to put those fossils into perspective. It also helps us to understand when we see extinction events. Right? For example, it explains why the dinosaurs didn't make it through the KT extinction. They just weren't very well adapted to the situation of the planet after that time, but mammals did, and they even thrived eventually. The geologic timescale itself is actually constructed based on fossil evidence. So when you think about it, the way that geologists are able to frame time on Earth is directly related to the process of evolution. And we think about periods of Earth history in terms of what animals had evolved to be prominent at those specific times, right? So studying the fossils tells us about time, and studying the fossils tells us about what the Earth was like at that time, right? So it informs us of past environments. For example, if you look at fossilized plants, in the past, they would be very well adapted to the environmental conditions of the past, and you can use that to say something about past atmospheres. You can do the same thing with certain shelled organisms in the ocean, and you can use those as climate indicators. Another example would be coal. Coal only forms from the remains of subtropical plants that only existed during the Carboniferous. And those subtropical plants obviously can only grow in the subtropics. So anytime that we see coal in the geologic record, that's actually a fossil because it provides us with evidence of past life, and it tells us that that place, say it's in Indiana, we have coal here, used to be a warm subtropical swamp at some time in the past, right? So it's really our understanding of evolution and our ability to put fossils into some sort of order and use them to talk about Earth history provides this really strong connection between earth science and evolution. This concludes a video lecture of evolution and earth science. Hopefully this video has drawn on your past experiences in some of your biology classes and from your time trilobites in T-Rex class, and possibly paleontology if you took that course. So this was just meant to be a broad review. Hopefully you found it useful. Explore the videos below for a little bit of extra information, And don't be afraid to reach out if there's anything you would like to review in greater depth.